By the end of lesson 1.8, you should be able to solve absolute value equations, and you'll do that using this formal definition here, or using an idea in here. So here we have an informal definition. This also, we could call this a geometry definition. And it's a geometry definition because it has to do with the distance. So the absolute value of a number, and we use these symbols here to represent absolute value, is a number's distance from 0. We know that distance is never negative, so a number's distance from 0 on a number line. And then the algebra definition, or our formal definition, says, or it gives this definition as an equation. The absolute value of x equals, and it actually splits it up into two parts. This is known as a piece function, but it splits it up into two pieces, and it depends on what x is for which one you use. So the absolute value of x is actually equal to itself. It's equal to x. So when it says x, this just means it's equal to itself. And I'll use that phrase a lot. If x is greater than or equal to 0. So if x is positive or 0. That's what this x is greater than 0 means. Positive or 0. And the absolute value of x is the opposite of x if x is less than 0 or negative. And so we're going to try to talk through these. We've heard absolute value before, so we know it, but let's talk through this using this algebra definition here. So find the following absolute value. So absolute value of -3. We're going to think of this. Well, it will equal itself if x is positive or 0. Well, our value is not positive or 0, it's negative. Or it equals its opposite if x is negative. So we want to look at this. So what's the opposite of -3? Well, the opposite of -3, remember we use a minus sign for opposite or negative. So the opposite of -3 is actually +3, which we knew that the absolute value of -3 was +3, but here we use that definition. Absolute value of 72. 72 is positive, so it fits this part, so therefore the absolute value of 72 is itself, so just 72. Absolute value of x. Here's these last two, or we have to actually write this in two ways. Honestly, we have this up here, but the way that we think about this, we might ask, well, is x positive or negative? And the answer is we don't know. It's just x. X could be 15 or it could be -11. So we have to, when we think of absolute value of something that involves a variable, we have to split it up. And if it's positive, so the top part is if it's positive, the absolute value of x is equal to itself if x is positive or 0, or greater than or equal to 0, and if x is negative, which we don't know if it is or not, so we have to put both of these in here, it's equal to the opposite. And all I did here was rewrite the definition, the algebra definition. Might be helpful, I wrote it in these words here before. So this last one, it's not just x, it's x plus 6. Well, is x plus 6 positive or negative? Well, we don't know. It depends on what x is. If x is -100, it's negative. If x is positive 100, it's positive. So we have to split it up again. And what we'll do here is we'll say, well, it's equal to itself. So it's equal to just x plus 6 if x plus 6 is greater than or equal to 0. And it's equal to the opposite, so we put a negative. Remember, we do opposite here. The opposite of x plus 6 if x plus 6 is negative or less than 0. And so we had to break it into two parts. And that's going to be the idea we'll use when we solve these absolute value equations, and later when we solve absolute value inequalities. We're going to take something that looks like this and we'll have to write it 2 times. So that's the idea behind it. All right, so we're going to go ahead and solve some absolute value equations here. We're going to isolate the absolute value on one side of the equation if necessary. A lot of times it's already isolated. That means get it by itself, just the absolute value. Apply the definition of absolute value to write two equations. So we're going to use the definition because we're not going to know if it's positive or negative, so we have to write both. Solve each equation, and then we have to check our solutions. So in here, or doing this first one, we want to isolate the absolute value. Well, it already is isolated. It's by itself on the left side. Apply the definition to write two equations. Well, is 2x plus 9 positive or negative? And the answer is always we don't know because we don't know what x is. So we have to split up into two parts. So here's how I usually do it. So if it's positive, if 2x plus 9 is positive, what do? Well, the absolute value is equal to itself. So we just write 2x plus 9 is equal to whatever's on the other side, 8x minus 3. Well, what happens if 2x plus 9 is negative? 2x plus 9 is negative. It's equal to its opposite. The absolute value of a negative is equal to its opposite. So we actually do the opposite of 2x plus 9, and we have to put the parentheses because it makes the whole thing negative, and we'll distribute that negative, equals 8x minus 3. Now, I know this is a process that you can learn, but I really want you to understand what we're doing with splitting this up into the two parts. If it's positive, the absolute value of 2x plus 9 simply equals 2x plus 9. If it's negative, 2x plus 9 is negative, the absolute value is equal to the opposite. And now what we do is we solve these individual equations. So let's just finish this. We could subtract 9 from both sides. And then to get the x's on that side, we can subtract 8x from both sides. And we'll have negative 6x is equal to negative 12. Divide both sides by negative 6, and we get x is equal to 2. Over here, we have to distribute this negative, so we have negative 2x minus 9 equals 8x minus 3. We'll add 9 to both sides. At the same time, we'll subtract 8x from both sides. And so now we have negative 10x equals 6. Divide both sides by negative 10. We get x equals negative 6, or 6 over negative 10. This should be 10. Reduce and simplify, we get negative 3/5. So there's our two answers. We want to check both of those, so we're going to put them back into our original equation. Putting in 2. So we think our answers are x equals 2 and x equals negative 3/5. So we're going to check to make sure they both are true. So we're going to put 2 in for x. So the absolute value of 2 times 2 plus 9 is equal to 8 times 2 minus 3. Well, this is 2 times 2 is 4, plus 9 is 13. So we have the absolute value of 13. Does that equal this? 8 times 2 is 16, minus 3 is 13. That works. So x equals 2 is definitely one of our answers. Putting negative 3/5 in. So we have, absolute value, and we're going to put negative 3/5 in for x. 2 times negative 3/5 plus 9. And we want to see, does that actually equal 8 times negative 3/5 minus 3? 2 times negative 3/5, we can put this over 1, because this is an absolute value, not a 1. So we multiply here, we get negative 6/5 plus 9, the absolute value of that. Does that equal, so I should put a question mark here. Here we have 8 times negative 3/5 is negative 24/5 minus 3. Now, I'm not even going to finish this writing it all out because we can figure it out here. The absolute value of a positive is positive. So over here, we're going to get a positive number. Over here, we have a negative minus 3 is going to be more negative. So we have a positive and a negative, so a positive cannot equal a negative, so this does not work. So negative 3/5 is not part of the solution, so our only answer is x equals 2. So we didn't have to go all the way through that because we saw a positive can't equal a negative. All right, next one here. Let's separate this here. And we want to solve this. We want to isolate it. Well, it is isolated. We want to apply the definition. So if x plus 5 is positive, we know that the absolute value of a positive is itself. So we just keep this the same, is equal to 9. And then if negative, x plus 5, if x plus 5 is negative, the absolute value of it is the opposite. So we need to do the opposite of x plus 5. Equals 9. And then we solve each of these individually. Here we subtract 5 from both sides, which would give us x equals 4. Here we distribute the negative, so negative x minus 5 is equal to 9. Add 5 to both sides. Negative x equals 14. And divide by negative 1, x equals negative 14. So those are our two answers. Let's check. This is pretty easy to check these because we can put them right in here. Does the absolute value of 4 plus 5, does that equal 9? Well, 4 plus 5 is 9. The absolute value of 9 is 9, so that works. This is correct. And then plug in negative 14. Absolute value of negative 14 plus 5. Does that equal 9? Well, negative 14 plus 5 is negative 9. And it is true that the absolute value of negative 9 is 9. So that means x equals negative 14 is also correct. So this one has two answers. Our last one here, isolate the absolute value. Well, we do have to do something here. We're going to add 8 to both sides to isolate the absolute value. And we get absolute value of 3x minus 12 equals 32. Now we have the absolute value equals a number. We can apply the definition. So if 3x minus 2 is positive, the absolute value is equal to itself, so we can keep this the same. And if 3x minus 12 is negative, we want the opposite of this. So the opposite of 3x minus 12 is equal to 32. And we'll solve both of these individually. Here we'll add 12 to both sides. So 3x is equal to 44. Distribute, you got negative 3x plus 12 equals 32. Subtract 12 from both sides. Negative 3x equals 20. And should have finished here, divide both sides by 3. So x is 44 thirds. Or over here, divide by negative 3. X is negative 20 thirds. So those are our two answers. We should check those. We'll plug in 44 thirds. This looks like it might be hard, but it doesn't turn out bad because the 3 will reduce right away. So 3 times x, just 44 thirds minus 12, minus 8 equals 24. Again, I mentioned before, these will reduce. 44 minus 12 is 32. The absolute value of 32 minus 8, does that equal 24? Yes, because the absolute value of 32 is 32 minus 8 is 24. So this works. And then let's check the other one. So 3, negative 20 thirds minus 12 minus 8. Does that equal 24? These reduce. Negative 20 minus 12 minus 8. Does that equal 24? Well, this is negative 32 minus 8. Running out of room here, but this is absolute value of negative 32 is 32 minus 8 does equal 24. So both of these answers are solutions. And that is solving absolute value equations.